Cool. On our way. So part of the reason I started diving into this topic of, are modern object-oriented languages actually, object-oriented in the traditional sense, is after being a C# developer and really diving into .NET, I started getting exposed to environments like Smalltalk. And that really kind of started to tweak my way of thinking. And it was kind of like, okay, when I started digging into Alan Kay and really looking at some of the research that like Dan Ingalls did, it was just like, are all these languages that we're using today, are they object-oriented? So, are they? Like I said, I'll run through a couple slides, and then I really want to break this out to make it kind of more conversation-driven. So are these modern object-oriented languages actually object-oriented? Well, okay, I ruined my own punchline. Yes, I think they are. But I don't think that's the important question to ask. I think the important question to ask is, do they adhere to the spirit of object-oriented code? The kind of things that were originally done or original goals of object orientation, do they exist today with some of the modern languages, whether we're talking about Java, whether we're talking about C#, whether we're talking about Ruby, or so on and so on and so on. So a couple quotes that are some of my favorite quotes. This is perhaps on the top, a quote from Alan Kay, father of Smalltalk. I actually made up the term object-oriented, and I can tell you I did not have C++ in mind. Well, we can argue that some of the modern languages that we use in a lineage standpoint, type systems and everything, that may actually have more in common with C++ family of languages as opposed to like Smalltalk. If we look at this medium from, C++ stuff over to here to, late binded and late bound languages like Smalltalk. Alan Kay has another quote that he's talking about why he feels there's a lot of power behind object-oriented code. And he lists, here's the things that are important. And yeah, of course, he talks about encapsulation and messages. But then he kind of leads it off at the end by saying, and bind everything as late as humanly possible in the entire pipeline. So with late binding at the core of the essence. Another one, this is actually from a video that Dan Ingalls did when this is 1989 while he was at Apple. You can actually find this out on Google Video, where he's going through what is object-oriented code, and of course using kind of Smalltalk as the medium. And he goes on to say, there's a simple test that I like to run myself through to determine whether something is actually object-oriented or not, whether a language is object-oriented or not. So let's say we have a rectangle class. Rectangle has points, of course, as members. But in the context of that, can you actually define a new kind of number, let's say a rational number, complex number, or something like that, use it in a normal rectangle without having to change the code for rectangle? You don't touch that code. You just create a new number type, plug it into an existing instance of rectangle, and can the system blacken the rectangle and actually work? Well, the thing is, today, C#, if you go to implement that point class, is it going to be an integer? Is it going to be a float? Is it going to be a double? What type of number is going to be represented by, the points by the coordinate system? Well, yeah, you can get around that with generics, make them generic parameters, so you can specify, okay, this is of float, this is of int. But the thing about going that route is something that comes up is this idea of ceremony versus essence. The idea of how many hoops do you actually have to jump through in order to express your underlying intentions? So are there a lot of hoops I have to jump through to get around the compile system before I can express what I properly want the language to express? Another quote that I like, especially when it comes to ceremony versus essence, is that a designer's work is not finished when there's nothing left to add, but when there's nothing left to remove. This idea of breaking things down into the bare essence. In the musical field, we talk about this a lot. There's a lot of people that like to just slam all sorts of shit into products. Whether it's using all the latest and greatest beats, whether it's, I'm going to have this really complex chord that's here. Well, the thing is, often that's not the best thing to do. You want to break it down into the sole essence that expresses what you're trying to say. So one of the arguments when I go out there and talk to people on dynamic languages, common arguments that I hear, well, yeah, dynamic languages are nice, but I don't get compile time safety, I don't get reliable refactoring, yada, 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 list goes on. But the thing is, do you really not get that stuff? One of the things that blew me away when I started using Squeak is I started writing code, writing some methods and classes, and then I mistyped one of the local instance variables, one of the class variables. And I went ahead to go ahead and tell Smalltalk, go ahead and do it. And it popped up a dialog that says, we don't recognize this. Are you sure this is what you meant? Perhaps you meant this instance variable instead. And I was just like, well, goddamn. It's not, I would be led to believe that's something that I didn't get from dynamic languages. And then, of course, looking at design patterns, looking at unit testing, looking at refactoring, the lineage of all that stuff is Smalltalk. So a lot of that stuff grew out of the Smalltalk language. You look at some of the stuff Ward Cunningham was doing. You look at Kent Beck and all those guys. Look at a lot of the guys that are kind of the leading thought men on the object-oriented front. Yeah. A lot of them aren't Smalltalk, or a lot of them are Smalltalkers. So what do you guys think? If you're using C#, Java, anything like that, you could argue that Ruby and Python, especially Ruby, actually has a lot in common with Smalltalk. Kind of Smalltalk for the real world is the way I've heard it described some of the time.
Always expected Smalltalk to succeed, I just didn't expect it to be called Ruby.
Always expected Smalltalk to succeed, but didn't expect it to be called Ruby. I like that quote. Come on, I know there's some static language junkies in the room that are kind of itching to speak up and say how much of an idiot I am. Because I know I'm an idiot, just point it out for me. Oh man, nothing. Yes.
I have a question. Do you think you need derivation?
Do I think you need derivation? I don't know, do you think you need derivation?
Well, maybe of interfaces, but not of implementation.
What do you guys think? Derivation, do you need it? Do you not need it? Oh man, are you guys okay, maybe I should make you guys all stand up and do jumping jacks. Well, I mean, I could do it, but I obviously have other problems that jumping jacks would solve.
Just a thought that I have when I've seen your test whether a language is the right object-oriented language, whether you can plug any new number into an existing rectangle.
Yeah.
The language I thought of where you can do it quite easily is Haskell. So I'm wondering whether Haskell is object-oriented language then?
Well, actually, that brings up a good point, because when I've been out there talking to people on F#, one of the most common misconceptions I hear people say about F# is F#'s a great dynamic language. I'm just like, whoa, hold the horses. Dynamic language? What are you smoking and where can I find some?
It's a dynamic language, but it's not dynamically typed language.
Right. The very aggressive type inference that you get in F# where it automatically can infer the types in a generic way is very impressive.
If you go to the What is F# Microsoft page, dynamic is one of the words to describe the language.
Really? Oh, and damn, and Luke and everyone else is out of the room. Hey, Luke, if you're listening to this online 2 weeks from now, you fix that, bro. Dynamic is one of the words on the F# page describing what F# is.
Also on Wikipedia, functional and multi-paradigm are the first two words that describe C#.
And of course, Anders isn't in the room. I guess I'm not cool enough yet.
I've had
There's the one. There's Eric. What do you think? F#. Amanda was pointing out that on the description of the F# page, that it actually lists itself as a dynamic language.
Yes.
Yes, it does. It says that.
Because if you have reflection, what is dynamic language, they all compile down to reflection. So everything that runs on the CLR is a dynamic language.
Some are just better than others.
Looking at the research.microsoft.com page right now, I think they might have taken it off because
Did they?
it wasn't one of the bold words before.
Yeah.
It's not there anymore. So.
It does say it supports many dynamic language techniques.
No, but that's right. No. That's an absolutely fantastic point. I know when I started to dive into F#, I would do something and I'd be like, well, shit, I only thought that was possible in dynamic languages. I'm not specifying types anywhere here. You know, and let's say the return type from a function can actually change depending on the generic type that's passed into the function. You know, that kind of stuff is just like, well, I guess that all is possible in F#. Yeah.
So I started looking at a language called Mozart, which is the multiple platform version of Oz. And it defines itself as 12 different paradigms. So I think that the lines are kind of blurring.
12 different paradigms. There's a time where you're just breaking down categories to just break down categories.
Right. So I'm thinking that maybe the word could become so blurred that they don't really mean
I have a language that's object-oriented, class-oriented, prototype-oriented, dynamic, strongly typed, statically typed, yeah. Yeah, concurrency-oriented, that's a good one, yeah.
Oz's whole thing, though.
Yeah.
Which
That's kind of Oz's whole thing, which
Right.
is super multi-paradigm or whatever.
Exactly.
We solve world cancer.
All these languages and paradigms, and we haven't solved cancer.
Yeah, what's up with that? Hey, but we spend a lot of money on the military budget. Oh, I'm really sorry if that offends anyone. Just please don't shoot me. No other thoughts?
The thing I think about when I read this, about can you define a new kind of number and all that, is, I mean, let's apply the, not 80-20, 99-1% rule. I mean, I come from an applications development background, and I've never needed this. So, do you really need that?
Right. Do you need it in the real world?
But this is really a test of to what extent is the system deeply runtime bound. And in particular, there should probably be a condition, and you don't have to recompile.
Right. Well, I almost come...
Things like F# get it.
Right.
Oh, well, you can do this, and now it's a new type.
Yeah, well, I'm even coming from the C++ background of, or I should say C++ background of object orientation, we talk about the open-closed principle. Well, right, it's...
A man much wealthier than he told me that.
I'll let that slide, because that wasn't my point. So I'll give you that one. So it's the idea of the open-closed principle, which we refer to in .NET a lot, is the idea that a class should be open for modification, or open for extension, but closed for modification. So I should be able to extend the behavior of an object without ever having to touch the source code whatsoever, which is a common principle that we talk about in object-oriented design. Yeah?
What you just said was invented by iPhone.
There you go. It was, actually. You're right. I just came across that the other day, and I was just like, oh, what a surprise. Another thing from Eiffel. Yeah. Open closed principle. Absolutely. Let alone designed by contract and all that juicy stuff. Out of time?
Still ticking. Yeah,
It's up to you, man. You can say, get your fat ass off the stage. I'm not going to be offended.
I give you 15.
Jeez, no laughter? Man. Usually that whole insult yourself goes over really well in Europe. Okay. Yes?
Well, I think that the real question is not exactly how well we implemented object-oriented paradigms, or how much we screwed up the original idea of Allen Key. So, there is the fact that there are several understandings today of what object-oriented programming is, and it's not important that we have several of them, actually, the terminology. Most of the people probably associated what we have in C#. It's class-based, strongly typed kind of thing. I think the real question is, and actually the real world gets in as we expand our horizons, and we start to compute and model everything, and it's more and more in the real world. It's not like in 80s or 70s, we were just computing things, something. Now it's almost about everywhere. It's about modeling the world, and we hit the wall. For example, in my particular area, we really hit the wall with traditional paradigms of object-oriented programming. So the real question is...
Who's ever next can come up and start setting up.
So the real question is what we are missing, how we need to extend the paradigm, whatever it's called, to really meet the challenges.
Mm-hmm.
And for example, I think one of the coolest things in dynamic languages is that the admission that the world is too big, and they need to specify in advance all the types that I'm going to work with. Like, for example, if I'm going to manipulate objects in Microsoft Word, I need to import all the assemblies and all that shit. So it becomes almost impossible. So I have to admit that I would skip this and do it dynamically.
Right.
So it's actually the fact that the world is too complex to account for this in advance.
What was
the admission of the fact? So I think the question is, it's not about terminology. What is pure or real object orientation, but how we will advance our concepts to meet the challenges.
What I find interesting is that Alan talks about now that he wish he never would have used like the term object, that he thinks the really important part that should have been taken away was messaging. That this idea of loose coupling that's enabled by messages that are flying around a system is the important part. The thing is, I wonder how much damage we do when we're teaching others that object-oriented code is all about ISA and HASA. Trying to model the real world in that aspect. I honestly wonder if that's more damaging in the long run.